So yeah, when we do, so basically, uh, when we do algebra and all those problems we are doing, is really just help us to be uh, familiar and with the properties, because those properties we got to use them to solve problems that are we have not seen yet. And uh, remember, we got really come down to we have uh, three sets of rules, or they call three sets of properties. Yeah. So one set is about operator, and in algebra we got addition and multiplication. And another set is about equality, and another set is inequality, greater than or less than. And as far as the um, operator goes, addition, multiplication, and we have this, A plus B equals to B plus A, and A times B equals B times A. So do you remember what property is that this called?
I do too.
No, no. Hello, Jet.
Hello.
Yeah,
Commutative?
commutative. Very good.
Oh, right.
So that's basically what things we need to know about those properties. So otherwise, we don't really learn, uh, uh, doesn't really learn even though we might be able to do some problems, but we haven't really learned the essence of algebra. Okay, we got this property. Then we have another one is A plus B plus C is the same as A plus B plus C, or A times B then times C equals to A B times C. So basically this one says, as far as addition and multiplication concerned, which two you do first really doesn't matter. And you can see this is different from order operation. Order operation is for elementary school math. And so now we actually kind of one higher level math. That means we got at uh, higher how to say perspective to looking at math problems. Um, okay, remember what this is called?
Associative?
Associative, yeah.
Mhm.
It's called associative. It's kind of like free association, whichever two we start first, really doesn't matter. Now, this is different from order operation. Order operation says, as long as we dealing with the same operator, we go left to right. And this one tells us really doesn't matter. Well, so how come on order operation, we have to go left and right, and when we go doing algebra, then it doesn't matter. It's because now we are at a higher level looking at things. So it's where we got a little bit more freedom. It's kind of like just when you're learning anything, say sports, when you just started, there are some rules. But once you get much better at it, then you become more, you have more freedom. Okay. Then we got this, A plus 0 is equal to A, and A times 1 is equal to A. And do you remember what's that called? Anyone? So this tells us there's two special numbers, 0 and 1. When you add 0, it does not change the value. When you multiply 1, it does not change the value of the number. So this is called identity. Okay. And then we have this, A plus its opposite should equal to 0. And A times its reciprocal, that is 1. And anyone remember what's this called?
The inverse property?
Yep, inverse property. Very good. Now we have this A times B plus C. We got the parenthesis, and that equals to A times B and A times C. Or we can go A plus B times C. That is AC plus BC. And what's this called? Oh, hello?
Distributive.
Yeah, it's called distributive property. And that's basically what we got as far as we're talking about operators, add, multiply. So basically this rule tells us what do they mean by that. What's when we say add something or multiply something, what we mean by that. Okay, so now we're going to looking at the second set, which have to do with equation, which is actually pretty simple. Is we only have two properties. One is if A equal to B, then A plus C equal to B plus C. And this is called addition property. That means we can add this exactly the same thing on both sides. Then we have this, if A is equal to B, then A times C is equal to B times C. And this is the multiplication property. Multiplication. Okay. Then we're dealing with inequality, less than or greater than. And sometimes we just write like this, means less than or greater than. Just can save some time. Then we have basically the same two properties. One is if A equal to B, then A, sorry, not equal to. If A is greater than or less than, then A has to be greater than or less than if you add a number, same number on both sides. Good? Let's see if I can make that a little bit. Okay, are we good on this one? Okay, and then we have the multiplication property. If A is greater than or less than B, then A times C is greater than or less than B times C. Now we can see there's two possibilities. Has to do with if C is positive. If C is positive, we just keep the same sign. But if C is negative, then we have to flip it. I had to flip the sign. Good. Yeah, that's pretty much those are the rules. You could call the rules or call the properties. I think I think it's better just call them rules of algebra. And so that means when we doing algebra, we had to follow these rules. Okay, and the first thing we learn actually is in algebra 1, we'll learn how about linear equations. You can see how that get used. I'm going to use as example. Say 2x plus 3 equal to 7. Okay, so the first thing we do is minus 3. Now, what property we are using here?
Distributive?
Nope.
Oh, oops.
Nope. Nope. So when we're doing, this is the equation. When we're doing the equation, we minus 3 on both sides. Why can we do that? What's our property? Huh?
The addition property?
Addition property, exactly. Because minus 3 is same as adding -3. So it's addition property. So if A is equal to B, then A plus C is equal to B plus C. So remember when we're doing math, math is about logic progression, is that this is something we call given. And this problem, someone given to us. Now, what we are trying to say, we're not going to argue about this equation. We're not going to say this is probably not true. We're saying, given this, what would happen, what X can be. So our process is so-called logic deduction. Okay? We're trying to figure it out, deduce what X is based on the equation. Another way kind of looking at this is our clue. We're trying to figure it out. What is the truth? Okay, so -3 on both sides, even though this property tells us we can add anything we want as long as they are same. So the C could be any number. But the reason we add -3 is because we want to get rid of 3. And our goal here is to figure out X equal to something. So therefore, 3 has to go, 2 has to go, but we have to play by the rules. Okay, we can just not take them. We have to, by playing the rule, we -3 on both sides. Then this side, we got 2x plus 0. And this side, we got 4. And then we know 2x plus 0, just 2x. And what is that property? So while using this property, a plus 0 is equal to a. So what's that property?
Identity.
Identity property. Very good. We need to know that, because if we want to find out our answers, we have to be able to skip the reasons. So each step, actually, by using these rules, that's the reason behind why we think those are true. So each step we say, oh, this is our first step. Now we know this has to be true. As long as this one is true, this has to be true. And as long as this is true, then this is true. Okay, and then we're going to multiply half on both sides. And what is that property we're using?
Multiplication.
Yeah, multiplication property is if A is equal to B, then A times C, B times C. So as long as we're using properties, then we can solve the problem. And if we violate any of those properties, then we'll get wrong answer. Okay, so now we have knowing half times 2 is 1. 1 at times x, this side is 2. So the right-hand side, normally just numbers, it's pretty simple. But the 1x, just x. So x is 2. So that's how we found it. Good, you can see that. Very simple equation. We used addition property here. We use multiplication property here. We use 3 plus -3 is 0. That's our inverse property. And then we use the identity property from here to here. And we use multiplication property here. Then there's inverse property, half times 2 is 1. And 1 times x is x, that's identity property. You can see that very simple problem, but we use pretty much all the properties except absolute distributive. We haven't used yet. Good. Yeah. So when we're doing math, it's all about knowing the rules and then how to use those rules. Yeah. So if we only be able to solve problem we have seen before, then it doesn't mean it doesn't mean we have really learned it. If we have relearned algebra, then we should be able to solve problems that we have not seen yet, because we know the rules. Okay, just play by the rules. Okay. Are we good on this one? Yep. So the first thing we did is the linear equation, and we also did system equations. is actually some pretty early on last year. You can see that the rule get applied the same way, same rules, like the x plus y equals to 4, then 2x plus 3y equals, let's say, 15. Okay, so how do we do that? Remember, the rules still the same, and there's not, we're not making up new rules. So what we're going to do is, we see there's two variables, and so far we learned how to solve one variable problem. And so our strategy is to change this two variable problem into one variable problem. And so that's our strategy. But in order to do that, we have to basically get rid of one variable, either x or y. And we have, if you remember, we got two ways of doing it. One is called elimination. Another one is called substitution. Okay, now elimination is just basically we're trying to get rid of one variable. But now you can see here, we got two equations. So far, we won't be able to get rid any of the variable. If we use the bottom minus top, then we got 1x here, 3y minus y is 2y, still got two variables. But we can see that what happens is, what if we multiply 2 on the first equations, then we should get 2x plus y and equals to 8. Now, what property we just used? We multiply 2 on both sides of the equation.
Multiplication.
Yeah, multiplication property. Good. Yeah, those are things you should be able to know and be able to say to when you see it, you know, okay, that is that property. Good. And yeah. Okay, now we have that. Now we can see, we can use distributive property here. We got 2x plus 2y equals to 8. So this way, basically, we change this equation. Let's call that equation 1. We change that to equation 3. And those two are equivalent. That means they're basically the same equation, but we express in a different way. Okay, now we have that. Then we can see we can get rid of y. Oh, sorry, x. So what we're going to do is we use equation 2 minus equation 3. And 2 minus 2, 2x minus 2x, it's just 1x. 3y minus 2y, we got y. Then on this side, 15 minus 8, we got 7. So that's how we find y. Now, I've been using equation 2 minus equation 3. What property that I just used?
Is it additive?
Yep, it's addition property or additive property. Good. We minus basically the same thing on both sides because we have the equation here. This side. Okay, so we find the y equal to 7, and then we just can plug in either to this one or this one or this one. Doesn't matter which one plug in. So of course we want to do something, find some easier ones. So what we're going to do here is if I plug this into here, then we got x plus 7 equal to 4. Then minus 7, can you see that? We use the addition property. Then x has to be equal to -3. So now that's how we're solving it. And we start with two variables. We made some change and we got rid of one variable. Then we got one variable linear equation. Then we solve that, find the value of one variable. Then we plug in to the original equations. Then we find another variable. Good? Okay. So I'll have you do one. And while you do it, just make sure what kind of, what kind of properties you use. Okay.
Hmm. Hmm. Oh, I remember how to do this. I think.
Well, if you don't remember, you should be able to use what the rules, the properties to solve this.
I don't think I remember the properties.
No, you need to know all those properties. Yeah, otherwise it doesn't really
Okay.
you didn't really learn algebra. Good. And there's not that many, right?
I think I'm thinking of a different equation, but I don't remember how to solve. I don't remember the steps to solve this specific one.
Well, see if you can figure it out on your own.
Okay.
Yeah, so our strategy is to get rid of one variable. Once we find it, then I know now we use something called elimination. Okay, we just went through that. Okay, good job, Tammy.
Huh? I don't know. I don't understand that. Yep, I don't.
Oh, you should know. Figure it out. Okay. Remember the rules, the same rule. I mean, we have simple rules. And you know the strategy. We're trying to eliminate one variable.
Oh, that's what you're wrong. It's 5. That still doesn't help though. Oh no. You've gone from 2x plus 2y to x plus 7. Hmm. I don't know. I don't.
Well, you can treat this as a new problem, but based on what you know, based on the properties, and how do you do that? Okay. It's kind of like you play chess. It means there's
So
rules.
I think I remember. So what can in this situation can I can multiply the first or the equation on the top by 2, right?
What's that?
In order to solve it, so then I can subtract. So I'm gonna multiply the the equation on top by -2 in order to divide them from each other. Maybe I'm looking at this the wrong way.
Well, think about what he's trying to do here. What we're trying to do here is get rid of one variable. Okay. So how can get rid of one variable? And we did it early on by subtraction.
We could multiply, or I guess we could subtract I don't know. What would you do?
Yeah, I still know how to do this. Yep.
Because I remember doing this. I just don't remember, the steps.
What, this is the thing, if we don't remember it, we should be able to figure it out based on what we know. Good,
Okay, okay. Let me
Yeah.
just try to solve it.
all right.
And I had it. Right.
And he knows the strategy, okay? We want to get rid of one variable. Which one is up to you? Should we get rid of X? Should we get rid of Y? That's up to you.
Yeah. Yeah. Yep.
Yes, Chad?
The 2x plus 2y equals 1. We don't know y or x.
So what method should I use then to solve this?
But remember, we were using elimination. Yeah.
Okay.
Now, early on, I showed you how to do it. Do you understand it?
Okay, so the elimination method then?
Yeah.
Okay, yeah, let me do it real quick. I was just making sure. Okay.
Yep, I did some. Yeah. Unless you divide 5. But that doesn't make any sense because it doesn't work that way. Yeah, I'm done.
Hello, Chad. You good?
Not really. I don't understand how to solve for this.
How about the, when we go through example, do you understand it?
When you went to the example, I don't get how you. Wait, no, that doesn't make sense. Yeah, I don't understand how you jump from 2x plus 3y equals 15 to x plus 7 equals 4. I just don't understand that. How you jump from one number to the
Okay.
next.
Okay, well, very good. So let's see. On which part?
So it'd be like right here where it says x plus 7 equals 4.
Well, we did this one minus this one.
Oh,
That's how we get rid of x. Oh, sorry. Not this one.
So that's 7y.
2 minus 3. Oh, this is something later on. We find y first. That is
Yeah,
something later on. So 2 minus
Okay, that makes
3,
sense.
2 minus 3, what we got here is 2x got canceled, right?
Oh, yes. Now I see.
3y
Okay.
minus y, so we got y equal to 7, right?
So yeah, that doesn't cancel out.
Well,
Did I
2x
get it?
minus 2x canceled out, right? X got canceled out.
Yeah.
Then we got the only y left. Good.
Yeah. No, the one I'm seeing, the x's wouldn't cancel out.
For what? For this problem or next problem?
Next problem.
Well, it depends
Unless
on
that's
how
a
you,
3. Yeah, that's a 3. Well, yeah, it still doesn't make any sense. So,
well, if you want to cancel out x, what do you do?
well, I could subtract the. Let's see here. So I subtracted the first equation from the second.
Well, if you do first to second, it does. You still got two variables.
Yeah, so I got 2x plus y equals 5. And then I distributed the 2 to the x and y. So I got 2x plus 2y is equal to 5. But if I subtract that from first, I'll get 1x is equal to 4. So I end up solving for x rather than y.
That doesn't matter, as long as you can get rid of one variable. So
Okay.
yeah, what's your x then?
So if we go here, go there, that'll be x is equal to 4.
No.
Nope. Okay, never mind then.
Okay,
Well,
let's go over this.
I'm
Okay, make sure you understand every step. Okay, and the first thing we need to decide on is which variable to get rid of. This is really up to us. Now, if you want to get rid of x, this is 3x. Then we have to do is multiply 3 on the first equation.
Did I get it right?
3. Nope. We got
Oh.
3 times that equals to 12. Yep. Are we good here?
Oh, that would make sense. Hang on, let me copy this down.
Okay. So now we got 3x plus 3y equals to 12. Then, of course, the reason we do that is because we want to get rid of x. So that's why we multiply 3 on this equation, and that's our multiplication property. Okay, so now we got those two equations, 2 and 3. So if we use the 3 minus 2, what do we have?
I'm
And
so
on the
confused.
which part?
So I did the elimination method, but I guess I did it a different way. There could have I guess there are like several different ways you could have done it.
Yeah, you could have different way. Depends on how you which variable you're trying to get rid of.
Yeah, so I mean I technically didn't do it wrong, I just did it another way.
Okay. Well, make sure you understand what I'm doing. Good.
Okay.
Now, the reason why do I use times 3 on both sides for the first equation? Yeah, Usher.
Yes, sir.
Why do I times 3 on both sides of the equation?
Because you're trying to create common variables so you can subtract from one from the other.
Which one? Be more specific.
We can subtract the lower one by the top one. We
Oh.
multiply the top by 3.
Well,
That means
we're
we're trying to get rid of one variable so we can solve
one?
for.
Yeah, which one?
I guess we can get rid of x in this case.
Yeah, because that's the reason I multiply 3 on both sides.
Mhm.
So I can get rid of x. If I want to get rid
Okay,
of
so
y,
I solved for y first. I subtracted y, then I did solve for x after that. So
well,
I did it another way.
if you want to, well, if you want to do get rid of y, so instead of multiply 3 on both sides of 1, we multiply 2. So that becomes 2,
Yeah, that's what I did.
2y equals to 8, right?
Mhm.
Yeah, are we good here?
Yep.
All right, and now we can see if I use 2 minus 3, 3x minus 2x is x. 2y minus 2y, that cancel. Then on the right-hand side, 9 minus 8. Because we did left, we minus this side minus that, then this side has to do the same thing. That's
Wouldn't that be negative x? Because
3x
2
minus,
minus negative 3, that would be negative x. So that would be negative 1 x or just negative x.
well, I'm using 2 minus 3. So 3x minus
Minus-
2x, that's x.
Yeah, that would be.
Then on the right-hand side, 9 minus 8 is 1. Good?
Mhm. Yeah.
Okay, once we have that, then we just plug in, it really doesn't matter which one. If we plug in on the top one here, then we got 1 plus y equal to 4, then minus 1 on both sides, then our y will be 3. Good?
I wrote out my equation wrong.
Yeah.
I
Oh,
just
good
realized
here.
I wrote it out incorrectly.
Yeah. Make sure, do you understand it now?
Yes, sir.
How do that? Jeff? Yeah, make sure.
Okay, I see how we get. I see how we get y.
What?
Yeah, I understand it.
You good?
Yep.
Okay. Morgan, you good?
Yes.
Has to be very absolute, okay? 100%. Make sure. Any part not sure?
I'm still a bit not 100% sure. I don't know why I'm struggling with this particular problem compared to all the others as much as I am, but I think I do understand it a lot better than what I did earlier. So
That's good. That's good. Any step here not quite sure?
it's the beginning because I know all the factors in the rules. It's just the beginning where I know how to distribute them. It's just I'm struggling for some reason to figure out how exactly to distribute them and when to actually narrow it down so that I can eliminate. Or
Okay.
no, wait, elimination is the first step, right?
Right. Well, actually,
Yes.
before we eliminate, we have to do something. That's why since we're going to get rid of y, then because there's 2y here, that's 1y. So we multiply the first equation to get our third equation. Good?
Okay.
Yeah.
Yeah,
Well,
I redid the equation. Did I get it right?
yeah, good job. And then we use top minus bottom, right? Then we use 2 minus 3 and 2y minus 2y, y is gone, and that's why we make 2y. And 3x minus 2x is 1x. And on this side, 9 minus 8 is 1. So once we find x, then we plug in to, it really doesn't matter which one to plug in, but we just plug into the one which is simple. This top one is really simple. Then since x is 1, 1 plus y is 4, then y has to be 3, right?
Yes.
So again, when we're doing math, it's about logic deduction. We got some clues here. This is given. Then we just using the rules to work it out. Okay, I'm going to give you another practice. Hopefully, I mean, this whole thing is help you to getting familiar with the rules. So let's still do that. And this time we do 2x plus 5y equals and 15. Okay, let's see how it works out. Yeah, again, it really depends on, doesn't matter which one you want to get rid of. But you have to pick one. And of course, you want to pick a simple one, as simple as possible.
Okay. Two x is equal to 15. Okay. So 3y is equal to 1.
Hi, struggling with this one.
Good job, Tammy. Good job, Jet. Just
Yes.
you got the y, now find the x.
Okay.
I'm confused.
Oh, in the world am I
You're
gonna find it?
kind of dealing with fractions, okay? Yeah,
How in the world am I gonna find x? Okay. Ooh. No. Okay. How can I get it so there's only x left? Like you. So that'd be
yeah. Good job, Asher. You got it.
x. X plus 4y is equal to
Just a minute, I'll be back in a moment.
Mm-hmm.
x plus 4y to 8.
Is y supposed to be a fraction, or did I do
Yep.
it wrong?
Y is a fraction. Mm,
Hmm. Hmm. No. Okay, figure that out. So no. Hmm.
Well, let's see how we do this one, okay? Again, we need to decide which one to get rid of. And of course, we're trying to do things as simple as possible. So 2x, in order to get 2x, I just need to multiply 2 on both sides. So we got 2x on the first equation. So if we do that, then we got 2x plus 2y equals to 14. Then we can use this equation to minus this equation. 2x minus 2x, we cancel x. 5y minus 2y is 3y. The other side, 15 minus 14 is 1. So again, we are using addition properties here to do that. That's why we can do it. And then, of course, we divide by 3 on both sides. Then y is 1/3. Okay, Jet, are we good here?
Yes.
Okay. So once we got y equal to 1/3, then we just plug it in to the top one.
Oh.
So that becomes x plus 1/3 equals 7. Well, that's a simple linear equation. And we know how to do that. So minus 1/3.
Oh, my word. I forgot.
Then x will be 7 will be 21/3 minus 1/3. X will be 21/3, which is 7, minus 1/3. That gives us 20/3. So that's our x is 20/3.
So you didn't want it in like a mixed fraction.
You can use a mixed number. That's no problem. Mixed number will
6
be
2/3 is.
6 2/3.
That's what I sent.
Oh,
X.
I thought your y is 2/3. Okay. Okay. Yeah. X is. You got that right. What's your y then?
1/3.
Okay. Very good. Good job. Morrigan, we good here?
Yes, I think I finally have it.
Okay, very good. Let's try one more, okay?
Okay.
Okay. Good job, Tammy. Good job, Asher. Okay. Good job, Jet. Just need to do the X.
Okay, so I got to the part with 4x plus 4y equals to 16. I don't know exactly where to go after right after that one.
How do you got 4x plus 4y equals 16?
Do I?
Where do you get that?
Well,
How
oh, did I do it wrong?
how do you get to this step?
Okay, well, on the bottom you have 4x plus 3y equals to 15. So I multiplied 4 by the top ones.
Okay,
So 4 times x, then 4 times y, then 4 times 4.
you
and
got
that gave me-
4x times 4y, right?
Yes.
Equals 16. Very good. Then, yeah, very good.
Subtract that from the lower
Oh,
one.
okay.
Well, now the reason you got times 4 is you want to get rid this one, right?
Yes.
You want to get rid of that 4x. So now you just use this minus that. What do you have?
Oh, okay.
4x get canceled.
Well,
Then
then
4y minus
X is
3y is y. 16 minus 15 is 1, right?
Mhm.
Good.
Okay.
So now
Yes.
just need to plug in. If you plug in here, then we just x plus 1 equal to 4, then minus 1, then x is 3. Good.
Okay. Yeah.
Yeah,
I
very
just
good.
wasn't too sure if I was supposed with that. Wasn't too sure if I was supposed to subtract 4x by the top row or by the bottom row by new thing.
Yeah, it really doesn't matter if you use this minus that. If you do that, then you got negative y equals to negative 1, right? Then y is still 1. Good.
Okay.
Yeah, the reason I use the bottom minus the top is because this way I only dealing with positive numbers.
Yeah, that makes sense.
Yeah, because it's negative numbers, sometimes you make some silly mistakes. So it's trying to avoid that.
Yeah.
Yeah, Jet, are you good?
I'm golden.
Okay, how do you get x equal to 5?
Mm. So I plugged in y equals -1 to x plus y equals 4. And so it would be x minus 1 is equal to 4. So I added 1 to each.
Well, how do you get y equal to negative 1?
So I took 4x and substituted the 4 into the first equation. So that'd be 4x plus 4y equals 4 times 4. 4 plus 4 equals 16. Then I subtracted that from 4x plus 3y is equal to 15, which actually would be negative y is equal to -1. So therefore
Right.
y would be 1, which is
Yeah.
my mistake. So
Right.
therefore it'd be -1. So therefore x would be 4. Yeah, thanks for correcting me on that.
Oh, no problem. Well, that's why you can always check, okay? Just plug in a number and see if the equation is true. That's how we know whether or not we made some mistakes. Good?
All right.
All right. Very good. Very good. Okay. So that's what we have for today. Okay. Basically, we're going to do review, and our last day is the 15th. Good. So we got
So we're doing review. So what are we doing after next week?
next week and the week after, 2 more weeks, we're just going to do the review. Good. And then after that, I'll give you a final exam so you can work on that.
Scary. All
Good.
right. Sounds cool.
All right. Okay. See you guys.
See ya.
Yes. Thank you so much.
All righty.
Bye.
Thank you
Hey,
very
Dr.
much.
Canada,